You probably think that the world around you looks pretty much the same to every animal. Same blue sky, same green grass, same red car driving past you. But that's completely wrong. Some animals see colors that are literally invisible to us. Some can spot tiny prey from hundreds of meters away. Others see the world almost without color at all. And some don't even need visible light to find you. So let's take the exact same world and see what it looks like through the eyes of different animals. Let's start with an animal that sees you every single day, a dog. There's a common myth that dogs see everything in black and white. They don't. Dogs can see colors. They just see far fewer of them than we do. Humans normally have 3 types of cone cells responsible for color vision. Dogs have only 2. That makes their vision somewhat similar to red-green color blindness in humans. So imagine this. You throw a bright red ball onto green grass. To you, the ball immediately stands out. But for your dog, the difference between those colors can be much less obvious. Reds can appear much darker or more brownish. Blue is much easier. So ironically, if you're buying a toy that you actually want your dog to easily see, a bright blue toy makes a lot more sense than a bright red one. But dogs sacrifice some of our color vision for something more useful to them, seeing in lower light. So as the sun goes down and your colorful human world starts disappearing, your dog is still doing surprisingly well. But compared to our next animal, your dog basically has normal eyes, because now we're going underwater. Imagine jumping into the ocean. The deeper you go, the stranger light becomes. Red wavelengths disappear first, then orange, then yellow, until most of the world is dominated by blue and green. And sharks evolved inside this environment. For many shark species, color may barely matter at all. Research on shark retinas has found that many species appear to have only a single type of cone photoreceptor, meaning that unlike humans, and even unlike dogs, many sharks may essentially be colorblind. So instead of a colorful tropical reef, imagine something much closer to a world of brightness, darkness, and contrast. For a shark, the important question isn't necessarily, is that fish red or yellow? It's, does that shape stand out from the background? And in dark water, that's much more useful. Some deepwater sharks take this even further. Their visual systems are extremely sensitive to the limited blue-green light that penetrates deep into the ocean. So imagine you're swimming at night. To you, almost nothing. To the shark, a silhouette moving through the water, which is slightly terrifying when you remember you're the silhouette. And now let's go from an animal that lives in dim water to an animal that can see tiny details from ridiculous distances. Imagine you're standing on top of a building. You look down at the ground. There are cars, people, trees, but eventually everything becomes too small to distinguish. Now give your eyes to an eagle. Suddenly, the world becomes much sharper. Birds of prey have extremely specialized eyes, designed to resolve very fine details. Their retinas contain specialized regions with extremely high concentrations of photoreceptors, allowing them to detect details at distances where our vision begins to fail. So let's say you're flying high above a fuik. You see grass. The eagle sees something moving inside that grass, a mouse. And that's the important difference. It's not really like the eagle has a magical camera zoom. The image itself is simply being captured with much greater detail. Think of it like this. Human vision, 1080p. Eagle vision, someone just increased the resolution a lot. And birds have another advantage. Their color vision can also be substantially different from ours. Many birds are capable of detecting wavelengths extending into ultraviolet, meaning there are details and contrasts around us that can be obvious to a bird while being completely invisible to a human. But if you want to see just how useful ultraviolet vision can become, we need something much smaller. Here's a normal flower. To us, it's yellow. That's basically it. But now let's replace your eyes with the eyes of a bee. Suddenly the flower can look completely different. Bees don't see the same spectrum of light that we do. Their color vision uses photoreceptors sensitive to ultraviolet, blue, and green wavelengths. And that ultraviolet part is important because many flowers have ultraviolet patterns on their petals, patterns that you cannot see at all. To us, normal flower. To a bee, the flower can contain high contrast markings directing it toward the center, almost like someone painted a giant landing target on it. And these aren't just random patterns. UV markings on flowers can help pollinators detect and orient toward them. So imagine living your entire life surrounded by secret signs and having absolutely no idea they're there. That's basically what humans are doing. But there's something else interesting about bee vision. Red, which looks extremely obvious to us, isn't perceived in the same way by bees. Some red flowers can appear extremely dark to them, depending on how much ultraviolet light they reflect. So the human version of the world and the bee version aren't just different colors. They're built from completely different pieces of the light spectrum. And after seeing invisible ultraviolet patterns, let's go back to an animal sitting somewhere in your house right now. Except this time, Turn off the lights. At noon, your cat's vision isn't particularly impressive compared with ours. Fine detail? Humans are better. Rich color? Again, humans win. But then the sun goes down, and the situation starts to reverse. Cats are built for hunting in low light. Their eyes gather light extremely efficiently. And behind the retina is a reflective structure called the tapetum lucidum. Light that passes through the retina can be reflected back through it again, basically giving those photoreceptors another opportunity to capture it. It's also one of the reasons cats' eyes seem to glow when light hits them at night. So imagine a dark room. To you, a chair, maybe a doorway, and then mostly darkness. To your cat, far more useful information is still available. But there's a trade-off. Cats don't get superhuman night vision for free. Their vision sacrifices some fine detail and color discrimination in exchange for better sensitivity in dim conditions. So your cat isn't sitting in complete darkness, seeing the room like it's daytime. That's a myth. But in conditions where you're beginning to struggle, your cat has a major advantage. And that's useful when your ancestors spent their evenings hunting small animals. Speaking of finding warm, small animals in darkness, there is another animal that uses something completely different. Because our next animal can detect something your eyes cannot see at all: heat. Imagine you're standing in complete darkness. No moon, no lamps, nothing. Someone places a mouse a few meters in front of you. You can't see it. Now imagine being a pit viper, and suddenly there's a warm object glowing against the cooler background. But here's the important part. This isn't technically normal vision. Pit vipers, pythons, and some boas possess specialized heat-sensitive organs that can detect infrared radiation produced by warm objects. So their eyes are still seeing visible light, while a completely separate sensory system provides information about heat. The brain can then use both sources of information to locate prey. So while a human might see darkness, the snake effectively has access to an additional map of where warm objects are located. Mouse, warm. Rock, cold. Your hand, very warm. Which means hiding from one in darkness isn't nearly as effective as you'd hope. And if thermal detection sounds fast, the next animal makes you look slow. Extremely slow. You know this moment. There's a fly sitting on the table. You slowly move your hand closer, 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 and it disappears. How? Well, part of the answer is that a fly experiences visual changes much faster than we do. Your eyes and brain don't process the world as one perfectly continuous stream. They continuously receive and process changing visual information, and different animals can resolve those changes at different speeds. Small, fast-moving animals, especially many flying insects, can have extremely high temporal resolution. So a movement that looks fast to you can provide much more visual information to a fly. It's not literally living in permanent slow motion, but that's a useful way to imagine it. From your perspective, slap. From the fly's perspective, why is this enormous idiot slowly moving his hand toward me? And then it flies away. Again. This incredibly fast visual processing makes sense when you're tiny. If you're flying through a world filled with branches, walls, predators, and giant human hands, being able to react quickly is pretty important. But our final animal does something completely different with its eyes, because it can look in two directions at once. Imagine you're walking down the street. Your left eye is watching a car. Your right eye is watching a bird, independently, without moving your head. Congratulations, you're now a chameleon. A chameleon's eyes can move with a remarkable degree of independence. One eye can scan one part of the environment, while the other looks somewhere else, which gives the animal an enormous advantage when searching for prey while simultaneously watching for danger. So visually, its brain can receive information from two different directions. But then something interesting happens. Once the chameleon decides, yep, I'm eating that, both eyes can converge onto the same target. Now it can precisely judge where the prey is before firing its tongue. And that may be the strangest thing about animal vision. There really isn't one best way to see the world. An eagle doesn't need a snake's thermal detection. A shark doesn't need to see a bright red strawberry. A bee doesn't need human color vision. Every animal sees the version of reality that was useful for surviving in its own environment, which means the world you're looking at right now isn't necessarily what the world actually looks like. It's simply the version your eyes were built to see. If today you've learned something new or simply enjoyed the video, make sure to like it and write in the comments, which interesting animal did I skip?